Hi, good day and Assalamualaikum. My name is Nur Shahanim Binti Muhammad Shukri and my partner's name is Dr. Siti Emily Binti Jumaat. We are from University Tun Hussein On, Malaysia. For IMIC 2021, our projects are selected in Innovation Product or Project category. The project's title is ANN Artificial Neural Network based model for prediction electricity from wind energy. Now, I will start the presentation. We start with the first content, which is project description. Our project description is a growing demand for wind as renewable energy sources has given rise to attention in economic and technological concerns relevant to integrating power grids. Nevertheless, throughout Malaysia, wind speed varies according to region and month because it does not blow evenly and uniformly. However, there is lack of study to identify its potential. The objectives of the project are to identify and evaluate the potential of wind speed in Parit Raja, Batu Pahat, Johor to produce power generation. Therefore, one of artificial intelligence technique, which is an artificial neural network (ANN), has been chosen as a method to predict the wind power. The ANN method has the capability to predict the future system output values and gives good results for pattern recognition, identification, and classification of wind energy potential in Malaysia. All the wind energy's parameters involved are investigated and trained in MATLAB software. We move to the next part. The second part is problem statement. There are three problem statements, which are: first, it is quite difficult to find or estimate which area in Batu Pahat, especially around Parit Raja, that is suitable for implement a wind turbine because of the uncertain wind speed. In fact, wind turbines tend to operate in places with a lot of wind daily, which is more relevant than having sporadic high winds. Second, it is quite costly to develop and construct a big scale of wind turbines, and it will need high maintenance. The prediction of wind speed in a specific area needs to be made in the first place in order to minimize the cost and make project construction, operation, and maintenance planning more efficient. The third one, it is quite challenging to provide reliable forecasts of wind power that will decrease the occurrence or length of reductions that lead to cost savings, improve worker safety, and alleviate the physical impacts of severe weather on wind power system. The third part is project impact. These are some of society benefits. First, the community will be able to identify the amount of power that can be obtained if they use wind energy as a source of power. For energy planners and owners of wind farms, forecasting wind power production may be very useful. Wind power protects consumers by reducing the cost of producing electricity. The study results show that improved day-ahead wind power forecasts can significantly reduce operating costs and increase the reliability of large interconnected power systems, thereby increasing the overall energy efficiency of the power system. Lastly, wind power is green energy that generates energy from the wind by transforming mechanical energy into electricity without contributing any pollutants to the atmosphere, safe environment, and reduce carbon dioxide. Okay, next is project novelty. To prove that ours is a novel project, I'm going to explain on how we get our result analysis in details. Okay, this figure shows the neural network structure that has been constructed in MATLAB software for the project with 4 inputs, 10 neural numbers in the hidden layer and 1 output layer. Other than that, 70% training, 15% validation and 15% testing also has been set for the ANN model configuration. There are 4 input data uses for the project, which are wind speed, rotor swap area, air density, and bends limit approximation. In contrast, there are only 1 output data, which is wind power. These are the first step, which is construct the ANN block before gets the result. This is the table of monthly average wind speed data for 3 years in meter per second. I'm gonna explain year by year. Based on the results, the minimum and maximum wind speed values for 2018 are 3.532 meter per second in July and 5.380 meter per second in February, respectively. While for 2019, the minimum and maximum wind speed values are 3.561 meter per second in June and 5.783 meter per second in January. And lastly, the minimum and maximum wind speed values for 2020 are 3.446 meter per second in July and 5.996 meter per second in February, respectively. Okay, the next figure is monthly average speed versus power for 3 years. As you can see, the left axis is for speed and the right axis for power output. The minimum average output power value for 3 years are 27.844 watt in July 2018 and 23.940 watt in June 2019 and 23.234 watt in July 2020, respectively. On the other side, for the maximum average output power value for 3 years are 84.346 watt in February 2018, 99.233 watt in January 2019 and 120.651 watt in February 2020, respectively. Okay, we move to the next slide. The table shows the total power production for 3 years. The year of 2019 shows the highest total output power, which is 19.867 kilowatt, following by 17.556 kilowatt in 2020 and 15.905 kilowatt in 2018. Hence, this power production prediction of wind energy will benefit the renewable energy industry in the future. Okay, the next part is the plot regression of ANN configuration for 2018 on the left, and in the middle is for 2019, and on the right side is 2020. As you can see, they have the similarity of the values. They have approximately R equal to 1 for training, validation, and testing stage. The best R value was equal to 1, while the best MSE value was equal to 0. The aspect that should be considered is that the MSE value for training data must be smaller than the MSE value of testing data. In this case, all of the 3 years get MSE equal to 0. Now, we move to the future system for power production in 2021. This table shows the monthly average wind speed data and total power production just for 2021. In accordance with the minimum and maximum amount of power production for 2021 are 732.481 watt in June and 2.574 kilowatt in February. As we all know, Malaysia faces the southwest monsoon and the northeast monsoon wind seasons every year. It is proven that these monsoons give effect to the minimum and maximum values for wind speed and power production in June and February of 2021. Furthermore, the total output power through the year of 2021 is 15.603 kilowatt. Next, the figure shows the graph for a monthly average wind speed on the left y-axis in the bar chart and average power production on the right y-axis in the line graph for 2021. The highest number of average wind speed and average power production are in February, while the lowest numbers are recorded in June. The minimum value of average wind speed and average output power are in June, which are 3.651 meter per second and 24.416 watt, respectively. Moreover, the maximum average wind speed and maximum average output power values are in February, which are 5.678 meter per second and 91.923 watt, respectively. Okay, next, as you can see, figure shows the best curve fit for the ANN configuration of Pirate Raja that represented the performance of the ANN model to predict the power production in 2021. The ANN model has successfully predicted the power production with the best fit of plot regression, which is R. R value was approached to 1. The best performance for the values of MSE training, testing and validation of this model was approximately equal to 0. The data of the model could learn network very well during training, which shows that the MSE training was lowest compared with MSE testing, and it proved that the ANN model performed very well during training. Okay, now I'm going to show the demo for the simulation of ANN. Okay, this is how I get the error, plot regression, and plot error histogram, which is MSE. So if we don't satisfy with the result, we can retrain it again. Until we get the desired result, like this. MSE is approached to 0, all for training, validation, and testing. Also for R is equal to 1. You can see here the plot regression for training is 1, validation 1, test 1. All of these are equal to 1. This is how I get the error. So this is the power output generated by ANN. Okay, that's all from ANN simulation. We're gonna proceed with the last part. Okay, the last content is the project achievement. ANN-based model of prediction electricity from wind energy is achieving the objective. The changing of the wind speed for every month is based on monsoon wind season in Malaysia. Southwest monsoon is from May to October, and northeast monsoon or rainy season is between mid-October and the end of March, gives big impact to the results. Based on the results obtained, the data shows the enough amount of power that can be produced by wind energy. 2019 shows the highest total output power, which is 19.867 kilowatt, following by 17.556 kilowatt in 2020 and 15.905 kilowatt in 2018. Furthermore, the total output power prediction through the year 2021 is 15.603 kilowatt. It can be concluded that the power production from wind energy can be predicted for every year, including the future ahead, using ANN. Okay, thank you so much for your attention. That's all from me. Assalamualaikum.